Okay, this is lesson 3.3, characteristics of polynomial functions in factored form. Already we've looked at characteristics of power functions. So that's with a single term, like x to the exponent 7, x to the exponent 3. And we've started looking at polynomial functions, but in expanded form. So where you have multiple terms. For example, we could have like f at x equals 3x squared plus x minus 7. And that'd be an example of a degree 2 polynomial function or a quadratic. In this video series, we're going to look at the examples in factored form. In order to do that, though, we have to look at two key definitions. The first one is called a family. When you have a family of polynomial functions, it means that that set of polynomial functions will have equations that fit two characteristics. They'll have the same degree, and they'll share something else in common. So for example, they could share the same zeros or x-intercepts, or they could share the same y-intercepts, but same degree and same characteristic. This graph here demonstrates a family of polynomial functions in factored form that share the zeros. So in this case, we have x minus 2 as one factor, so one of the zeros is 2, and x plus 3 is another factor, so the other zero is negative 3. What makes them all family members is that they all share those characteristics and they're all degree 2 polynomials. The only thing that makes them different is the k value. And the k value in this case is, we may see this more familiarly as this is difficult to say. We may be more familiar with this as an a value, and the a value is the vertical stretch or compression. So in this case, we have three examples of vertical stretches or compressions. And we have one example where it's flipped, but if you notice, they all go through the same x-intercepts. So all of these polynomials belong to the same family. The second definition is order. Order means the exponent to which each factor in an algebraic expression is raised. So what's a factor? Well, a factor is this bracket here, this x minus 2 bracket, that's a factor. And the order of this factor would be, well, in this case, 1. If you don't see an exponent, it would be raised to the exponent 1, and the second bracket is also of order 1. So we have two factors, both order 1. Another example would be, say, f of x equals x minus 3 to the exponent 2 and x plus 1 to the exponent 4. This factor would be of order 2. And this factor would be of order 4, because the exponent on those factors are 2 and 4. Okay, now that we have a little bit of terminology down, we can look at how polynomial functions behave around zeros and how that's related to their factored form. So I'm going to roll down here, and we have three graphs with equations, and we're going to look at some characteristics. The first one is f of x equals a tenth of x plus 2 times x plus 1 times x minus 4 times x minus 5. What this shows us is we have 1, 2, 3, 4 zeros. And if we look on our graph, that means we should have 4 x-intercepts. And we do. We have 1, 2, 3, 4, and those x-intercepts should be at negative 2, which it is, negative 1, 4, and 5. So our equation matches our function, our equation matches our graph. What degree is this function? Well, in order to find out the degree, you want to add the order on each of the factors. 1, 2, 3, 4. The order on each of those factors is 1, so this means we have a degree 4 polynomial. Another way to find the degree would be to expand this all out and look at the first term in your expansion. Your first term would be the leading coefficient times x times x times x times x. And 4x is multiplied, give you x to the exponent 4, which means we are degree 4 polynomial. If we had a squared on this first x term, that would obviously change the 0, But when we're counting our factors, or when we're counting our degrees, we would count 2, 1, 1, 1 for 5. Okay, so watch for that when you have a squared inside. If you have a squared and a squared, that would mean you'd have 2 of these brackets. X squared times x squared is x4. So it would be the exponent here times the exponent there. So watch for any of those tricks when they may appear. The next part says order on x plus 2 factor. Well, the x plus 2 factor is this first factor. So the order of the x plus 2 factor is 1. And the next says the behavior around the 0 at x minus 2. So the behavior, well, what's happening as we approach that 0? Well, we're going through that x-intercept. So it's crossing that x-intercept. And it's crossing it fairly straight. There's a little curve to it, but if we look just in the circle here, we're going to say that it crosses it like a line. It goes straight through, so we're going to say it's linear crossing. If we look at our second example, we have this polynomial function that increases, then decreases, then increases, matched with this equation. A tenth of x plus 2 squared times x minus 2. What degree is this? Well, it would be order 2 and order 1, which makes this degree 3, because 2 plus 1 is 3. And the number of zeros, we have 1 0, 2 zeros from our graph. And this is called a double zero because it's of order 2, which means that you have negative 2 as a solution only, raised to the exponent 2. And then you have 2 as a solution as well. So you should have zeros at negative 2 and 2, which we do. The order of the x plus 2 factor. X plus 2 has a factor order of 2. And let's look at the behavior at that 2. At that 2, we are increasing, touching that factor, and then decreasing in a curved fashion. So we could say that that is parabolic or curved. So I'm going to call it quadratic. And we might start to notice something here between the order of the factor and the behavior. 1 being linear, 2 being quadratic. Let's see what 3 is. Our third graph, we have h of x. It's decreasing through a 0, and then increasing back up through another 0. If we look at the orders, we have order 3 and order 1. 3 plus 1 is 4, so we have a degree 4. How many zeros do we have? Well, we have a triple 0 here. Negative 2 is a solution. And we have a 0 here, 1. So that's 1, 2 zeros. And on our graph, we have 1, 2 x-intercepts. The behavior, the order of factor x plus 2. If we look, the order is 3. And what's the behavior look like? Well, we're decreasing and approaching and then continuing to decrease in the shape of a cubic. So if we try to draw some conclusions here, the degree of a polynomial is found by adding up the orders of all your factor brackets, keeping in mind what may happen if one of your factors has a squared inside it. And we'll look at more of those examples later. So degree, add up the orders. Number of zeros, you're looking to see how many factor brackets there are. So in this case, there's 1, 2, 3, 4, 4 zeros. 1, 2, 2 zeros. 1, 2, 2 zeros. Okay, we have a degree 4 because there's 1, 2, 3, 4. Degree 3 because of 2 plus 1 is 3. And degree 4 because 3 plus 1 is 4. The orders, if we draw some correlations to the behavior, if you have order 1 on your factor, it should behave around that 0 like a line, which means it should go through the 0. If we have degree 2, order 2, at our 0, we should approach and rebound off. And that could be in any way. It could come from down, from above and back up. And if we have a cubic, we should approach and then cross. So the order on the factor dictates what the behavior at that 0 is going to look like. Okay, thanks for watching. That's part 1. Please pick it up in part 2.